Welcome to Let's Classify. Here we classify things. Welcome to Let's Classify. Today we are going to classify the types of matter based on physical and chemical composition. Before classifying matter, we have to understand what a matter is. This universe is not empty. How we can say that? We can say that because we can see the celestial bodies, that is stars, planets, comets, etc. If this universe has a certain volume, then these celestial bodies occupies some part of it. That is stars, planets, comets occupies some part of the volume that the universe has. Not only celestial bodies, even you, the phone you are holding, the oxygen we breathe, the food we eat, all occupy space and as mass. Thus, we have given a common name to them, known as matter. Yes, we have given a common name, matter, to them. You may ask a question. Everything we see, we touch, occupies space and has mass. Then, is there anything non-matter? Yes, there is, but does not completely belong to non-matter category because of its dual nature. We call it light. Sometimes forms of energy like heat, sound are also classified as non-matter. Now you must have understood what a matter is. Finally, let me give the definition of matter. We can define matter as a substance that occupies space and has some mass. So everything that we can touch is a mass, is a matter. So everything in this earth that we can touch is a matter. We said the substance that has mass and occupies space is matter. Anything that has mass should obey laws of motion. Thus, matter has physical property. So, we can classify matter based on physical composition. This classification, that is the physical composition based classification, totally depend on intermolecular forces existing among the molecules. Now, we know that the first classification is based on physical composition. Now, let's see about the next type of classification. Since there are different kinds of matter around us, for example, each element in periodic table is different from each other. For example, we take oxygen but not carbon dioxide, because oxygen has some chemical property that carbon dioxide does not have. We can produce an atomic bomb from uranium, plutonium, but not from gold, because uranium and plutonium has certain chemical properties that gold doesn't have. Thus, we can classify matter based on chemical composition too. Thus, at last, we have two types of classification. One is based on chemical composition and the other one is based on physical composition. First, let's see about physical composition. On the basis of physical composition, the matter is divided into 5 groups. It is also known as states of matter. First, let us see all the states of matter: solid, liquid, gas, plasma, and Bose-Einstein Condensate. We would have seen the first 4 states of matter because it is all around us. But the last state of matter, that is Bose-Einstein Condensate, can be found only through expensive experiments. Come on, let's first find out how one state of matter is different from other by increasing and decreasing the temperature of the matter. Let us begin this from solid state. If you see the animation, you could find that the matter is currently in solid state. How we can say that? We can say that because the molecules or atoms in the solid does not move. That is, it has definite position. Solid always maintain a definite shape and volume. If you want to know more about solid structure and types of solid structure, you can watch the video given in the description. Now, let's see and increase the temperature of matter by energizing the atom in the form of heat. You can see that increasing the temperature makes the atom or molecules in the matter to oscillate or to move from its position. But after reaching a certain setting temperature, whatever heat you supply to the matter, the temperature doesn't increase. It has reached a certain temperature. At this temperature, the temperature remains constant because something is happening inside the atom that uses this heat energy. Thus, at this point, at this temperature, phase change happens and it is known as melting point, where the matter is going to have different properties and intermolecular forces, and this state is known as liquid state or liquid phase. In this state, the volume of matter, in liquid state, the volume of matter is going to be definite, but the shape doesn't remain definite. That is, it flows. Thus, it gets the name fluid. The substance which can flow is called fluid. In liquid state, it is also observed that whatever be the shape of the liquid, its upper surface is always plane. In this state of matter, the atoms or molecules move randomly from place to place. This process is also called as diffusion process. Now, let's again increase the temperature of the matter. Now you can see that the distance between the atoms is increasing further, and again at particular temperature, the states of matter is going to change from liquid to gas. Gas is the third states of matter whose shape and volume both are indefinite. Shape and volume are indefinite because the intermolecular forces, that is the forces between two atoms, is weak in gas state. Thus, gases can also flow. Thus, they are also called as fluids. Now, let's go further and energize the matter and excite the particles in the matter. By doing so, the temperature reaches extreme condition. In this condition, the matter exists in the form of plasma. In this plasma state, ionized gases are found. This plasma is the fourth classification. This state is found in stars, sun, where extreme temperature is present. Not only in the sky, even in our home, we can find this plasma state. Yes, the fluorescent tube and neon bulbs have plasma within themselves. Previously, we increased the temperature. Now, let's decrease the temperature as possible as we can. We know Kelvin is a scale used to measure temperature. This scale doesn't have negative reading. This means absolute 0 Kelvin is the extreme end of temperature scale. For this reason, Kelvin scale is popular in scientific application. So, So let's take the matter to this extreme end, that is 0 Kelvin, that is absolute zero. Absolute means absolute. You cannot go behind it. It is the minimum temperature present in this entire universe. Bose-Einstein Condensate is a group of atoms cooled to absolute zero. When they reach the temperature, the atoms are hardly moving relative to each other. They have almost no free energy to do so. Energy is required for motion. At this point, the atoms begin to clump together and enter the same energy states. They become identical. That is, one atom is identical to other from a physical point of view. And the whole group starts behaving as though it were a single atom. To make a Bose-Einstein condensate, you start with a cloud of diffuse gas. Many experiments start with atoms of rubidium. Then you cool it with lasers, using the beam to take energy away from the atom. After that, to cool them further, scientists use evaporative cooling. With a Bose-Einstein condensate, you start from a disordered state where kinetic energy is greater than potential energy. You can cool it down, but it doesn't form a lattice-like structure that were found in solid. Instead, the atoms fall into the same quantum states and can't be distinguished from one another. That is, one atom becomes identical to another, all the properties were gone. Now it has same property that all other atoms have at this state and obeys what called Bose-Einstein statistics, which are usually applied to particles you can't tell apart, such as photons. You have to remember one thing about this Bose-Einstein condensate. It is the fifth state of matter. Here everything is equal and identical. That's